Where you at, bro? There's bro.
Oh, I seen it.
I already got stuff for me. Probably, yeah.
All that thing you said.
You got any more? What about you guys over here? I need to wait on two. Does not think it's done great. Who won?
It's the thing you want them to
Yeah.
say. No.
Is there any good? Bryce, is you good? Gabriel? Yep. Not bad for you.
I think most of them.
There's no drawings in number 2. Number 4. Then you do here, the blue structure.
Yeah, more to
Now, up to my desk.
Let me get
You know,
Oh my, oh. You want to come back to that class. And I don't want to.
You got a pen?
Pencil. When you got pen, pencil. Now chemistry.
Oh, that's a food.
And tell me what you got.
Here's mine.
That's the we're not sitting down. That's not
Lily, you can bring
Becca, you got anything?
It's okay. I'm about
You wanna do that? All right, remind me in a second when I'm doing my ink pen and I'll sign it in.
Yeah, me too.
Okay, I have this folder.
I need the game now.
Table's not here.
Have this one.
How about there? You put it on my laptop?
I did.
When do you need it by?
Anytime this week, I was out.
Okay. Alicia, you got homework? Let me see it. Bring it up here where I'm at. All right, what you got? Nope, I didn't have this.
Excuse me.
These comments.
And then I start writing the,
Okay, we did it.
what I need?
You got them all answered, so you get 100. I'm taking long to fill that out. Fill out what you got. So you're saying what I'm looking at. It's got more than 25. Well, I can see the meters. I'll give you a 50.
That is deserved. You're missing 75.
Brian, what you got? 7 seconds. Who's having this thing? Leandra's not here. Jennifer's still not here. And Rebecca, that leaves me you.
How many questions?
You want to use that? All right.
Okay. That's you know what? Like, in my hallway, can I use it? What does it?
What's the dude that I hung to? What's the dude that I hung to? There's more shoes. Did I hung to?
We have Gabriel, we have Rebecca, we have remember, the opening, you will not see this for an opening tomorrow, and this is what your quiz will be on. Leandra. Kevin.
I really put that on.
Destiny.
I got this good.
Alice here, Bryce, that's Emma, Prince, Ellie, Ron, Alicia, Blake, Tim, Dylan, and Juliana.
Still eating. You're gonna leave it alone. These are the ones that fit. You know.
Right.
Where's he at now? He was in Florida. Yeah. Is he here today? Got him on Snapchat. I like all the snaps he made, like, man, you feel me? Yeah, he out here, you feel me? What you doing yesterday? We got a free donut. Yeah, you know, we went to Red yesterday. We was chilling there, you know, Melody was there. Yeah, so we asked her what she did with the donuts.
You should come.
She said it's over there.
I just changed my whole
box of fruit.
No.
Got a lot. Alexa,
Anybody got the first one drawn?
Yes.
All right, go draw, Thelma.
Where you go?
Hello, it's me again.
What you doing?
Are you gonna do so much here, Maxie?
I have we have an SAT. Did you take it? Oh, I'll make sure.
Oh, I forgot.
What time is it over?
All right, tell me what's wrong with Simon's drawing.
There's something wrong?
Mm-hmm. If this was the quiz tomorrow, tell me what would be wrong with it.
There's an A on C.
No,
Is it
the
eight
C
where?
doesn't
On the C, how many's on the C? There's only 6, so what do we gotta do? Take one off of where
Yes.
and put it where?
The line on the CS. Oh, shit.
Well, that's confusing. Where is that H going?
Isn't this stuff that was left out?
Yeah.
All right, now it's right. So, who wants to tell me the geometry? Sal, get out of the way. All right, so, triangular what?
I got Lanier.
All right, it's triangular planar. What's the difference between planar and pyramidal?
Yes.
All right, son, where'd you put the pen?
Oh, I didn't see the red.
When you look at the central atom, all right, which is right here, how many atoms are coming off the C?
0.
How many atoms?
3.
The H, and the S. Everybody good with how they counted and got 3? All right, how many lone pairs are on the C? 0. 3 and 0 is why it's triangular planar. And in order to be triangular pyramidal or triangular pyramidal, there would be 3 and what on the central atom? 1 lone pair. All right, that's why it's not triangular pyramidal. Everybody okay with that? All right, the second one. Who wants to draw AS? What's wrong way? ASBR3.
I can do it.
No. All right,
I
Hema.
did
No,
that
no,
right.
Hema. Let me have Eric. Draw ASBR3.
Let's do this. Let me.
You've already drawn one for today. Let me have somebody else.
Right. There you go.
You don't even have to add up the electrons. If you know how many are there, just draw it.
Alright, that's why you have to take the standard contrast to self-esteem. Something like this.
I'm really hungry. I have biscuits here.
There.
All right. Questions about Eric's? Any issues? Is it drawn right? Does he have 8 on everything? Yes. Does he have 26 electrons drawn in?
Yeah.
Yes. His is correct. What geometry is his? Triangular pyramid. All right. And the last one. Let me see what we need to draw for the last one.
Where'd you get 26 from?
You have to add up the electrons.
Each line.
AS has 1, BR has 3 atoms, and then AS is in group 15, so it has 5 electrons. BR is in group 17, so it has 7. So you get 5, you get 21, you add it up, and you get 26 electrons. All right, and the last one I need drawn is CI4. Let me have Bryce. Draw CI4. Oh, quickly.
That's why we learning something fun today.
Huh?
We're learning something fun today.
No. Not at all.
I'm so worried I'm gonna touch. On this wall.
You want to use all that?
What? Because we don't get on them. I'm such later.
You have what left? It doesn't look like you used one, so that leaves you with 2. Yeah, you only have 3. Strike.
Oh my God, my mom's I never put in my story, but I sent it to the group chat.
Oh, Snapchat.
What's your name?
You see how I got 32, Tevin? You see how I got 32?
And sure, just leave it. Yeah, she really likes it. It's not that hard. Just
Yeah, don't put them on the side of the lines, put them on the outside. This is the one on top where you got that straight up.
Is that 32?
Yes.
All right, so does Bryce have 32 drawn in, and does everybody have 8?
Yes.
All right, so what geometry is this one?
Textural.
All right, it has 4 eyes and no lone pairs. So we have tetrahedral. All right, 4 and 0. Now, any questions about how we got the? I didn't write that one down. That was triangular pyramidal. All right, everybody okay with the geometries? Now, tomorrow on the quiz, there's 6 of them. You either know them or you don't know them. Now, how do we decide if it's polar or non-polar?
If they have all dipoles are equal.
All right, are all the dipoles equal on this?
Yes.
No. This bond and this bond are the same. What about this one? It's not equal, is it? So that makes it polar. All right, the next one. What can you tell me about all 3 bonds?
There is no polar.
All right, all 3 bonds are the same. All right, does it have no lone pairs?
Yes.
Does it have no lone pairs? It's got lone pairs. So that automatically makes it what? Polar. It's got to meet both. It doesn't meet number 2, so that makes it polar. And the last one. Are the dipoles equal?
Yes.
Does it have no lone pairs? So this makes this one what?
Non-polar. That's what I'm.
That's the only one that's non-polar out of the 3. Questions?
So it has to have the same amount
Ms. Lloyd, you have another
for it to be non-polar.
paper, the one you gave us yesterday for the geometry.
Mm-hmm.
Can I get another one?
Shoot,
What'd you do with yours?
notes yesterday. All dipoles must be are
I
equal.
was getting my food paper. I think I threw in my opening too.
Not everybody.
Right. All right. Homework answers. Those of you planning to turn in late, I better not see you writing. Go back.
So,
Okay, so it's polar.
okay, so let's say it has 2 of the lines and 2 of the dots.
All right, this only has the structures drawn, and then after you've checked, I will go through and tell you the geometries and whether they're polar or non-polar. All right, in question 3, I've labeled this as an exception. All right, boron here only has 6 electrons. Okay, this is like hydrogen. It never gets 8 electrons. It just doesn't. It's an exception. All right, it does not form a double bond. Most of you probably drew it having a double bond because you made it have 8 electrons. It just doesn't have one. It only has 6.
So that only for boron.
That's only for boron. It's the only exception I'm going to teach you other than hydrogen. All right, number 6 is the other expanded octet I told you we'd do. You shouldn't have had any trouble when you did number 6 because it's just like the one we did yesterday that I told you just draw 6 around it and put 6 lines. Okay, so you shouldn't have struggled with number 6. Number 3 is the only one on the paper that should have caused any issues. Boron and hydrogen are the only 2 exceptions we're going to do.
Problem?
Hydrogen would be the only one you'd see on the exam. I don't think you'd see boron. All right, have you got a chance to check 1 through 6? Can I turn?
Oh, this is homework?
Yes, genius.
Oh.
All right, there's 7 through 12. Now, on 8, if you drew your double bond between N and Cl instead of N and O, that's okay. If you drew your double bond between N and O instead of N and Cl, that's okay. All right, it's just called a what form again from yesterday? A resonance form.
Ms. Wallace, how's the code gonna be laid out for tomorrow?
Exactly like this. You'll have to draw, I think, 6 Lewis structures, tell me 6 geometries, and tell me polar, non-polar for 6 molecules. All right, and sorry, I'll go back.
Okay.
And there's 13 and 14.
Oh, I did that wrong. Yeah, that's how I did it the first time, but then I changed it
Why?
because I moved the line and I put it like under the O's and beside the O under the O on the left and beside the O on the right.
So you had O, and then you did what?
Okay, the line, and then I just put dots. And
And like this?
yeah, and then the same.
Like that?
I
Now,
did like that the first time. Like,
all right, well, the problem with this is you have 2, 4, whoops, I'll try that again. You have 2, 4, 6, 8, 10, 12, 14, and you can only have 12 electrons, and that has 14. So you got to take 2 off, okay? And when you do that, this only has 6 electrons now, so 2 of them have to do what? Got to share. So I got to take 2 from here and put them in the middle so that each of them have 8. That's why I double bonded. All right, and there's your backup page that I told you I'd go back for. Okay? All right, so if we go back to number 1, what geometry is number 1? If it has no central atom. Linear. What's number 2? What's number 2? Linear. All right, what's number 3 if it has no lone pairs and it's got 3 chlorines? Triangular planar. What's number 4? Triangular planar. What's number 5? Bent. What's number 6? Octahedral. It's got 6 bromines. It's the only one that's got 6 on it. All right, number 7.
Triangular pie something.
Triangular pyramidal. Number 8, bent. Number 9, tetrahedral. Number 10, number 11, triangular pyramidal. Number 12, bent. Number 13, tetrahedral. And number 14, linear. All right. Polar or non-polar? What's number 1?
Polar.
Nope.
I did that wrong. That's wrong.
Remember, when there's no central atom, you subtract their electronegativity. So if you look up I is 2.5 minus 2.5, and you get 0, so it's nonpolar. Same thing with 2. 2.1 and 2.8. So 2.8 minus 2.1 is 0.7, so that would be polar. All right, number 3 would be what? What can you tell me about the 3 bonds? Are they the same? Yep. What can you tell me about number 2? Any lone pairs on B?
No.
So it's what?
Non-polar.
Non-polar. All right, what can you tell me about the 3 bonds? Are they the same or are they different? Does the double bond change when you subtract N and O on this side and you subtract N and O on this side? When you look up the electronegativities, will the numbers be different if it's a double bond or it's a single bond? No. So for all practical purposes, this bond and this bond are the same. So the bonds are the same. Are there any lone pairs on N? So it's what kind? It's non-polar. Are the bonds the same?
Yes.
Are there lone pairs?
Yes.
So it's what?
Polar.
Are the bonds the same?
Yes.
Are there lone pairs?
No.
Guess what?
Non-polar.
You got it? So number 3 or number 7, what can you tell me?
Polar.
Number 8, what can you tell me?
Polar.
Number 9.
Non-polar.
Polar because the are
These 3 bonds are the same. This bond is what?
different.
Different.
Polar. What can you tell me here?
Polar.
What can you tell me here?
Polar.
What can you tell me here?
Heat.
What can you tell me here?
Non-polar.
What can you tell me here? When you subtract, you get 0. Questions? Now, that's your quiz tomorrow. Those of you who didn't do your homework and you can't draw a Lewis structure, you can't tell a geometry, and you can't tell polar and nonpolar, you're toast. Can't fix it for you. It's also the biggest bulk of the free response section on the test Friday. You got me? Okay. I told you that yesterday. I can't fix it for you, babe.
So on the test, it's gonna be like a mix.
You said what? No, this is.
The 51 questions of the 80 are multiple choice.
So what's the other 30?
Yeah.
So what's the other 51 about?
The periodic table and bonding. The other part of the free response come from being able to tell bond type, which we just talked about yesterday again to review since we've been out a week. How do we find bond type again? Somebody tell me how we found bond type.
We did some stuff.
Yeah, we did some stuff. Tell me what stuff we did to find bond type. Kyra, put that away, please.
Bonsai.
Oh, no.
If I said to you on the test, how do you tell me the type of bond between calcium and iodine? How would you find that answer? Sarah Ellie, how would you find the bond type between Ca and I? You would look at the what thing I gave you and subtract?
Electronegativity.
The electronegativity sheet, okay?
That's gonna be the question.
And you would look at the scale and see what it is, okay? So why can't you tell me that the first time I ask? That would be in free response. We know how to do that. The ionic structures we're going to learn how to do today, that's in free response. This stuff is in multiple choice. That stuff is in free response. Okay? All of the stuff on, if I give you 4 choices for atomic radius, which one's bigger? That's in multiple choice. If I give you 4 choices and I say which one has a +3 oxidation number, it's in multiple choice. Just because we were out of school for a week doesn't change anything.
I was in school for a week.
You were out of school for a week and 3 days. I can't fix it. Somebody bashed your head with their knee and gave you a concussion. All right. Now we're going to talk ionic bonding for the next little bit, and then we're going to talk about some properties between the 3 types of bonds. Now, for the last 2 days, the Friday before Easter and yesterday, we taught covalent bonding. All right? Covalent bonding
I can't seem to find my pen.
I can't fix it for you. All right? Covalent bonding was shared electrons, right? So, when it was shared electrons, we drew Lewis structures. Now, are we talking shared electrons when we talk about ionic bonding? No. What does ionic bonding mean from before the holiday break? All right, metals and nonmetals are how we recognize it. What happens to the electrons? They're not shared anymore. What happens to the electrons? There you go. All right, electrons are lost or gained. You can think of them as transferred. All right, electrons are lost or gained, or you can think of them as transferred. So, if we're trying to say that electrons are transferred, can I show them as a Lewis structure where we're illustrating share? No, we can't. We have to show them as something else. So, here, we're going to draw these as a balanced equation. All right, and we're going to illustrate where the electrons start and where the electrons go. This is not difficult because you guys already know how to draw Lewis structures or dot diagrams from way back on the last test. So this should not be difficult.
That's not scary.
Is it what? Off and on.
Right now it's better.
It may not be enough to cancel your game though.
I wouldn't have a game today.
You don't have a game today? Just practice? It might cancel practice if your coaches don't really want to get wet.
No, we practiced yesterday.
It was raining yesterday. Chances are you'll practice today. It's not supposed to be like a deluge or anything. It's just supposed to be intermittent rain throughout the day. So I suspect you'll practice regardless. All right, everybody caught up? You said no?
Now I'm a little sick.
Bryce said no. Okay, when you got it, Bryce? Okay. All right, so we're going to do a nice, easy classic. Sodium chloride, Na plus Cl, is a standard ionic compound. Now, on this side of the reaction, all right, you want to show the original placement of electrons. So, where do the electrons start? Well, look at your periodic table. Sodium is in group 1. So, how many electrons would sodium start with originally? All right, so sodium will have 1 dot. Chlorine is in group 17, so it would have how many electrons originally? So you're going to draw 7 dots on chlorine. Everybody with me so far? Now, from there, on this side, you're going to show, whoops, I didn't mean to draw 8. I meant 7, thank you. Show where the electrons go after the transfer. All right, so on this side, we're going to illustrate where they go after the transfer. Now, after having been in here for 9 weeks, plus, yeah, we're on 9. No, 11 weeks. I'll say we've only got 7 left, 11 weeks. You guys should all be able to tell me what's going to happen to the electron that sodium has.
It's gonna move over.
To,
CL.
all right, so on this side, we want to illustrate that that's what happens. So we're going to write sodium, and I want to show that the electron went to chlorine. So how am I going to do that? How am I going to illustrate that the electron left sodium?
8 dots on CL.
All right, I'm going to draw 8 dots on the Cl. Okay, so there you go. So dots on the atom that gained. That's one thing we're doing. Dots on the atom that gained, and the other thing I heard Hema said, which is what? All right, add oxidation numbers. So sodium gets a +1, and what's chlorine going to get, Hema? Go ahead. Exactly. Okay. Okay, so sodium got a +1 because sodium did what with its electron? It lost 1, and chlorine got a -1 because it did what? It gained 1. Okay, everybody with me? All right. Now that's as straightforward as it gets. Are they all that straightforward? No. Now we need to add one that's got a twist. Everybody caught up? All right, let's try. All right, so how many electrons does magnesium have? Okay. How many does fluorine have?
7.
Try not to draw 8 this time. All right, so what's magnesium going to do with its 2? It's going to lose it. And fluorine's going to do what? Going to gain how many? Can only gain how many if it's got 7? Can only gain 1. So it's got a homeless electron down here, right? Can magnesium lose 1, or lose 2 rather, and fluorine only take 1, and this 1 electron just be given off to space and be floating around out there somewhere? No, it's got to have a home. It cannot go back to the magnesium, and fluorine cannot have 9. So it has to have a place to go. Something has to be added out here for this electron to have a home. So what can possibly add over there to give that electron a home? Not an H, but what? Has to be one of these.
MG.
If we add another Mg, Mg is going to do what? It's going to give away 2 more, and now I have how many electrons need a home? 3. So, but if I add another fluorine, whoops, that did not work out real well. All right, if I add another fluorine, fluorine does what?
It has 7 already.
It has 7, so it needs what?
1 more.
It needs 1 more, so this one can go right up there and give it its 8th. So now I have a home for that one. Now, what is wrong with my equation? It's unbalanced. So what do I need to do? What do I need to do? Yep. Questions?
Oh my gosh.
You mean right at +2 right there?
Yes.
Yes, because the Mg is going to lose the 2. All right, I want you to see how far you can get with that one. See how far you can get with K plus that. Check to see what time we get out of here. I'm pretty sure I know. Let me double check. Yep, 12.
I know. You're just like, I don't know what to do.
Yes. Yeah, any bond was finished with 8 electrons, so yes, we will have 8.
I hate that.
So remember, you're going to combine them in a way that you're going to wind up with 8.
Wait, I think it's 6. 6 electrons? I thought it was.
Well, so, yeah.
Yes.
I'm good.
This one has 6. We got to add them up. That one gets 8. What? Need oxidation numbers on this one, and that one. You done 3 dots where you lost.
Miss Wall,
What?
come here.
We're good from there.
I have a question first. Is this how you do it?
Oh, I got it right. You gotta add it.
Okay, please.
Yeah, but
Wait, can I do it this way too? No matter. Well, I have to say like. A plus.
yeah, somebody has it. She skips it.
Yeah.
She kind of fast. She's gonna finish. Okay, I like how she asked it.
Oh,
You feel like that.
wait. You said what?
She missed so many days. She missed so many days already. Yeah, and she missed.
Too bad.
Yeah.
Saturday, May 6th.
Hello, come in.
Isn't this like in 2 months?
Oh, you sent me the pictures.
Damn it. Screenshot it.
No, you can replay it.
No, I already replayed it.
So we still have that. Harold, let's go to this. Let's go to this. What is that? You fix it. The
Alright, most people who I've already checked have the right answer. Alright, K has how many dots? Has 1. And O has how many? Alright, so K's gonna do what? And O's gonna do what? And that will only get us to how many? 7. So you said I need to add another K. And that means that I will wind up with 8 here. So you put a -2 there. And then you said I need a 2 there. Questions? Everybody good?
yeah, some people did K then plus K.
It doesn't matter the order that you put the K's in there. No, not at all. All right. Now, the only thing that matters sometimes is here. Now, some of you probably did 2, 2, and 2. The reason it's not 2, 2, and 2 is because of this, which most of you probably forgot and never even thought about. 2S and 2P4 would look like that with 2 together, 2 singles. And chances are I would not take off for it. But that's the reason a dot diagram. So if I just asked you a straightforward dot diagram on the test, it should look like this. It should not look like that. Do y'all remember that? Huh? Oh, yeah. Put it this way. I would certainly ask that on the test. You would certainly see that on the exam. Wow. Oh.
So I guess if you're not gonna take off one, you're not.
If I asked you to draw this on the test, which I will ask for one of these somewhere, if you drew O with this way and this type of reaction, no, I would not take off because it's only worth 1 point. Okay, and I'm not going to mark your whole question wrong for that. But if I ask in a question to draw a dot diagram, just a dot diagram, and I ask for oxygen's dot diagram, and you draw me this for a dot diagram, yeah, I'm going to mark it wrong.
How is it wrong? Wait, how is it wrong?
Because
When you write and draw a dot diagram diagrams are based on the outer shell. So when you draw oxygen, 1s2, 2s2, 2p4, what's the outer shell for oxygen?
4, 2 people.
All of the 2 is the outer shell. So 2s has how many lines above it? 2p has how many lines above it?
3,
All right. So how many arrows am I putting on 2s?
2,
And the 4 arrows for 2p. How would I draw the 4 arrows?
1, 2, 3.
1, 2, 3, and then 1. So when I draw my dots, My dots have to look like my arrows. So 2 arrows are together, 2 dots together. 2 arrows are together, 2 dots together, 2 single arrows, 2 single dots. That's the way a dot diagram is supposed to look based on the arrows. So if I just ask y'all for a dot diagram on the test, which I certainly would as part of the periodic table, then you should be able to draw that for me. But if I'm asking you to draw all of this out, no, I wouldn't necessarily expect you to do that. But if I just said, draw me the dot diagram of oxygen, yes, I would expect you to do that. This would be a multiple choice hint on the test Friday. This is free response on the test Friday. They're all same points though. They're 1.1, 1.2, something like that. Questions? All right. Now, the next part that we're going to do, next 2 parts are really just notes. Now, this part is fairly detailed. It does take a little bit of space. I would recommend probably an entire sheet of paper. Some of you may want to turn it sideways. You can do it full length, and I would recommend 3 columns. All right? We're going to subdivide your piece of paper into ionic, metallic, and covalent. Okay? Now, I tend to split it into boards. So one board's going to be metallic, one board's going to be ionic, one board's going to be covalent, and I'll jog between the 3 boards. All right? You could turn your paper sideways or long ways. It doesn't matter. All right? I'm going to start with metallic, and then I will go to ionic, and then I will finish with covalent. Now, I will be bebopping between all 3 boards, okay? And I will probably have to save these so that I have them for tomorrow, because I will probably not finish them before today's class is over. Now, we're going to talk about the differences between the 3 types of bonds and how they're related to van der Waals forces tomorrow, but specifically boiling point. And this is the last of the unit, and then we're ready to test, okay? So we'll finish tomorrow, and I told you the test would be on Friday. So on Thursday, am I spending all day reviewing Thursday? No, we'll have some time to review on Wednesday. So on Thursday, we're going to move on to the new unit, which is the gas laws. Those of you who like the math, we're going back into the math for a little over a week. All right, now, a metallic bond. This is the definition that I told you back when we started this unit. Was probably the weirdest of the 3 types of bonds. All right, because the electrons are donated to a region in space. The electrons are donated to a region in space. Now, when I say they're donated to a region in space, I mean that the electrons are moving or mobile. So, assuming that I can take a picture or a snapshot of a cross section of the metal. Assume my little pluses are the nucleus, and the little e's stand for the electrons. Metals are unique because these electrons can move throughout the metal and go wherever they want to go. Okay? The electrons move throughout the metal. They are the only bond that works this way. Ionic and covalent do not. So when we talk about properties of metals versus ionic and covalent bonds, this makes metals entirely different. Now, if you think back to properties that you learned about metals in middle school, well, you should have learned about them in middle school. If you had a real science teacher, you did. If you had a sub in a book, you might not have. What properties should you have learned about metals? Anybody know anything about metals? That's why I said, does anybody know anything about metals?
If you say something, it might come back.
Why should you not stick a fork in an outlet?
That's very conductive.
There you go. All right. So, metals are good conductors of heat and electricity. The reason that metals are such good conductors of heat and electricity are these moving electrons, right? If these electrons could not move, electricity could not flow through the fork. Or let's say you left a spoon in your pan of soup or whatever you were heating on the stove. If the electrons could not move, the heat could not flow up the spoon so that when you put your hand on the spoon, it would not be very hot or warm to the fingers. All right? Now, you might remember two words from science class. One starts with an M, called malleable, and one starts with a D, called ductile. All right, malleable can be rolled into sheets. Aluminum foil is a fabulous example of things that are malleable. All right, because the electrons can move, we can flatten metals into sheets. When you beat on them, the electrons just sort of squish out of the way. Say what?
What's that third one?
Electricity?
No.
Throughout the metal?
The D.
Ductile. All right, ductile or ductile, however you want to say it.
It's like when it breaks.
All right, ductile means it can be drawn into wires. The best example I can give you of that is copper. All right, we use copper in our wiring. Those of you who like jewelry, gold, silver, platinum, they're very malleable and ductile. Because they are, we can make lots of jewelry with those types of metals. Again, they are malleable and ductile because their electrons do what? They move around. So we can beat on them, we can mash them and it not break. Okay? Are you with me on that? Now, one of the other properties that you should have learned about metals is they are very lustrous. They have good luster, which means they are shiny. All right, now, not all metals come out of the ground being shiny, but we can shine them up with a little cleaner or polish and make them shiny. Now, the other thing that we want to say about metals is out of the three bonds, they have the strongest of the three bonds. And because they have the strongest of the three bonds, they are going to have the highest boiling point and melting point. Now, if you have the weakest bond, what will that do to your melting point and boiling point? It will make you the lowest. Who do you think is going to have the weakest bond out of the three types? Ionic, covalent, or metallic? Covalent will be the weakest. Everybody with me? All right, have I given you long enough to catch up or do I need to wait? That's all I'm going to put there for right now. I may think of something else in a minute. Oh, I didn't think about that. I think we're okay. I didn't put the conductivity tester there, but it's all right. I don't think I have to have that just yet. I can add that in if I want it. All right, everybody there? All right, ionic bonding. All right, in ionic bonding, I got to draw some really crappy pictures. Now, ionic bonding we've talked about a little bit, but I need to add in some new vocabulary words, and I have to draw some crappy pictures. And I'm sorry, but my ability to draw 3D pictures is like super crappy. Now, we've already talked about the fact that electrons are transferred. So I'll just stick that back up here just to keep it fresh. All right. Now, the thing that I want you to remember in terms of ionic bonding that makes it different from metallic is even though the electrons are transferred, the electrons are locked into position in a crystal. Now, generally, when we talk about an ionic bond, I want you to think about the fact that most ionic bonds tend to be crystals. Think about ionic compounds that you know. For most of you, the best known ionic compound is salt. It's one that you guys use, for most of you, probably every day. You may not sprinkle it on your food, but it's in most of your food. And when you think about what it looks like, most of you can visualize that it is a crystal. Maybe some of you even grew crystals. Did anybody have an elementary school teacher that y'all actually grew crystals in elementary school? All right, it started as a liquid. Maybe you put a paper clip or a string in it and you grew the crystals and it formed on the paper clip. Okay? If you did, it was an ionic bond that you grew. Now, when you grew this crystal, all right, there are essentially 7 crystal structures that you can make. And there are only 7. I'm not going to make you learn what the 7 are, but I'm telling you there are only 7. So every ionic compound that exists in the world has to fall within one of these 7 structures. All right? I can't draw them. I'm just putting that out there. Can't be done. I can't draw one. Now, I wish I had the ability to draw, but I just don't. So let's just assume that I can draw 3-dimensionally. I can't.
It's amazing.
Yeah, some fabulous stuff, isn't it? Oh yeah, I spent too much space there, so I need to shrink that a little bit. So picture that's a little smaller crystal. All right, now.
You said we don't have to know the 7 crystals.
No, just know that there are 7. Now, no, you got to draw it.
You got to.
Yeah. This is called a crystal lattice. All right. Now, I told you, I can't draw it either. Doesn't matter. Number of boxes is irrelevant. Just draw it. Now, the crystal lattice is one thing. And then the blue that I'm drawing over here is the unit cell. Those are the 2 things you got to have. The whole structure is the crystal lattice. And then the blue that I just drew in that, you know, are there is the unit cell. Now, the crystal lattice, let me change colors there, shows the entire network of crystals. And the unit cell shows one crystal only that determines, okay, shows one crystal only that determines the structure of the entire crystal lattice. So if we see the unit cell, then every other crystal is going to have that same structure. Now, I have tried to draw a what? What am I trying to illustrate? Yeah, I know it's a crystal lattice, but what structure am I trying to draw? Anybody know? It's really ugly, but it's supposed to be a what? A what? I heard it. It's a cube. Okay, cubic is one of the structures, and NaCl is actually a cube. Okay, so I would know that this. I know I changed the color. Come on, you dumb thing. There. All right, so I would know that this is a cube because my unit cell is a cube. All the other crystals also have to be a what? A cube. All right, so if one crystal is a cube, every other crystal multiplies as a cube. Okay, I can't have one as a cube and then the other one turns out to be rhombohedral or something else, or a hexagonal cube. It doesn't work that way. Everybody with me? Now, again, the electrons that are in this crystal lattice, can these electrons move in that lattice? No. Yes, sir. Yeah, in about 8 minutes, maybe less. All right, everybody caught up?
No.
All right, let me know when you have.
Okay.
All right, so how are these properties different from a metal? Now, what properties did metals have? They conduct, they're malleable, and they're ductile because the electrons do what? They move around. Do the electrons move in this crystal lattice?
No.
So, can they conduct? No. Can they be malleable? No. Can they be ductile? No. Now I'm turning the page. We're still in Ionic on your notes, okay? So, they are not conductors. They are not malleable. They are not ductile. Now, what do you know crystals are? If we hit them with a hammer, what happens to them? They shatter. So what's a good word for that starts with a B? Brittle. Okay? They're very brittle. Now, if metallic was the strongest bond and covalent was the weakest, these bonds are the middle strength bond. Okay? Now, when I say middle strength, though, they are not as high as metallic, but they are still pretty strong. Now, these bonds have something called lattice energy. All right, and I'm going to stop there for today, so you can tell me where I stopped for tomorrow, because I'm gonna need to know where I stopped. Now, I need